to mute myself in the in the broadcast channel so that I don't have that feedback, sound feedback. Okay. All right, so you guys got the data set. Inside this folder, there are 3 files. One is called shelf, another is called upright, another is wall shelf unit. And these are 3 families that we're going to use in the Mila project. Oh, you know, I did not share the Mila project. Well, it's going to be the same file from the last time. If you guys want, I'll just do that very quickly. This is the file. So I'm going to file save as. And we're just going to put it in the work in progress. Okay, you can grab this file as well, the file you see on the screen. I just save it in the drive. Okay, so last class I walked you through the process, the recipe of creating a new family from scratch. And we created this sofa, which is parametric family for the Mila house. Creating custom content is one of the skills that you're going to need to create things you can't find out of the box and that need to have a geometrical representation inside your projects. And so I encourage you to, when in the advanced class, I'm going to continue discussing the process of creating families. Advanced families include, for example, create a new door from scratch, or create a new window from scratch, or a new curtain wall panel that it's dissimilar from the out of the box. I just don't have enough time to go through all of those examples in a single class. But and so we created this piece of furniture, and it's a parametric furniture that has many types, and that has we have the ability to associate a material based on instance parameter. So these are instance material parameter, and this is a tip. Always always apply materials in the project, not inside the family editor, because that allows, it gives you greater flexibility to swap a material if you need to. If a material is applied inside the family environment, you have to open the family and then apply the material in the family. Whereas if it lives in the project, you don't have to transfer any material. The materials will be living there. And so creating instance material parameter is a good practice, particular when these families are reutilized from project to project, and you have to apply new textures. Okay, so, but what I really want to show you today is what we're going to do today is this exercise. It's create a more dynamic family. This is a shelf that it's adjacent to the 2 bedrooms, and it is fully parametric family. Let me show you some of the pictures of the Miller house, which you also have access. I like this project because it's very simple, and we can touch a lot of different topics without the complexities of a big project. But when I look at some of the as-built pictures, these are the final finishes of the house, and it has this built-in shelf unit. I think it's made of plywood or wood, and it's sitting between the two entryways into the main bedroom. It has five shelf spaces, and we're going to model it from scratch. It's a very unique type of furniture. So chances you're not going to find this anywhere in any library. And if you want to build something like this, then you have to build it from scratch and understand some of the rules of what it takes to build that. But I took advantage of this example to show you some of the parametric capabilities of Family Editor. When I say parametric capabilities, means associating behaviors to a geometry that responds to user inputs. And this family here, it's a parametric family because it responds to parametric inputs. In this case, I made all the parameters, instance parameters, and these are properties that drive the behavior of this shelf. And if I change any of this parameter, say the depth, then I get a new result. If I change the height, and notice how the shelves in between react, reposition itself in equal distance, depending on the parameter values. I can change the length. I can also change the amount of shelves that goes inside it, number of spaces that go inside it. I can do this to have 6 shelves, 7 shelves, 8 shelves. And so the flexibility to have a single family that reacts to user inputs, that is the power of parametric modeling. And so the way this family works is that it's made of different components. And when a family is nested inside another family, then it becomes a nested family. And in this case, we have 2 families here. The uprights, and the shelves. And then the shelf is array, and the n value that array shelf, it's also a parameter. What I'm going to show you today is how to assemble a family like this using nested parameters, nested families, and how to concatenate the values of the nested families into the parent families. In other words, the uprights and the shelf has parameters that are connected to the parent one. The parent family is the unit itself. This is the parent family, and that's the shelf unit. And the shelf unit has properties. It has a length, a depth, and a height. And then the shelf and the upright have also the same parameters, but they are concatenated. So when the parent changes its properties. The nested families associated with that family also update the parameters. And so we're going to review that process. All right, so I have already built for you some of these pieces, and rather than spending a lot of time building them, building all of the pieces from scratch, let's just review how the pieces were put together, and then we're going to assemble everything into to a single unit. So let me open the first piece, which is the shelf. And we're not going to do anything. I'm just going to show you how this shelf was put together. So I'm going to open a family, and in Google Drive, and you should have this in your end. You're welcome to open it as well. We did something like this in the previous exercise. So I think you know the steps. I started a new family using the generic model category. And the reason I use this is the generic model is the simplest template. It doesn't have built-in parameters. It doesn't have system family parameters. And it only has origin cross line. That's the start point. And all I did is add a new reference plane here, add another reference plane here, create an extrusion, give an extrusion a depth of 1/2 inch. You can see here. And then I created three parameters: the shelf length, the shelf depth, and the shelf material. The shelf material, it's associated with the geometry. This equal sign that is next to the material cell, it's a way to concatenate the material of the geometry with the type parameter. So we did this in the last class. I'm not going to ask you to do that again. These are the three parameters that we created. These are the material, the shelf length, the depth, and the material. And changes to the parameters will change the geometry. I'm going to change the length to 5 and see how this is the origin. And so from the origin, the length extrude forward. The depth is also parametric, 2 feet, 1 feet, and I'm just flexing it. And then the shelf material, it's this is going to be defined in the project environment. And so notice also that when parameters have this bracket called default, that means that they are instance parameters. So default equals instance parameter. Parameters are unique to that object. And when we create a new parameter from scratch, like we did last class, you have to decide whether it's an instance or a type. And for this particular example, I'm building everything as an instance parameter, meaning that every shelf in the project has the potential to have a different property. So very simple family, this shelf. This family is going to represent the shelf inside the shelf unit. And this ability of nesting families inside other families is really going to make the process of creation really simple and really less complex. If you think about the way I would create a parametric family like the one I show it, if I do it everything under a single session, then I need to think even more the math, the complexity, and all the properties needed to make it work. But when I nest component inside another component, it's easier to understand the logic behind it, and it's easier for your teammates to do some reverse engineering in case they want to understand what the logic was. There are families that you open it and you have no idea how they were put together because everything is in a single container and it has tons of parameters and it's so difficult to understand what is what. This is the typical shell. And you can recreate this very easily yourself if you feel challenged or want to do this at your own time. When I look at this in 3D, it's just a shelf. And when I look at it in the front elevation, it's a shelf that is sitting on the floor. The reference level in these families is the work plane of the family. So when this family is brought into another family or when it's brought into the project, the reference level here represents the surface that the family is going to be sitting on. And then the other thing to know in the family properties is that there are some parameters that are system parameters, like these guys, type image, keynote, model. We don't need this for this particular example. But if this is something you want to populate, then like cost, assembly code, this is information that can be retrieved at a project level in case you need it, in case that was important or relevant for, and for example, a mechanical equipment, if you want to include MEP information about the services that the equipment needs in order to create a schedule of equipment, then you would populate those parameters with the appropriate information. Okay, so 3 custom parameters, all of them were instance parameters. They were associated to dimensional constraints. I created 2 additional reference planes, an extrusion with a material associated with it, and that created this shell. So I'm going to close it and open the other one. The other component of this shelf, it's the uprights. And the upright, it's very similar to the shelf. Instead of modeling extrusion hosted by the reference plane, I created an extrusion hosted by the vertical reference plane. So let's open it. I'm going to open it here too. So the upright is here. And it is an extrusion. This is the floor plan, and this is the left plan. So the way it worked, what I did is just add a new reference plane, start a new family using generic model template. Then I added this reference plane to represent the height in the floor plan. I didn't, oh yes, I only added this reference plane to represent the edges, the right and the left face of the upright. And this is an extrusion that was created on the left view. You know, when I added the extrusion using the, actually, no, I did it from the floor plan. These are the sketch lines. The sketch lines are hosted at the reference level. They are 1 inch in thickness, and then the extrusion height is driven by a parameter called height. And the material is exactly the same way. The solid generated by the extrusion can be associated with a material parameter, and this material parameter will be defined at the project level. So there's nothing to take care of there. Simple family to create 2 parameters: the upright depth and the upright height. I did not take too care of the thickness. I'm just, in my mind, all of these materials have 1 inch thickness. But if we wanted to take care of the thickness as a parameter, we can also create a dimension, create a custom parameter, make it instance, and make it like upright thickness. So these were the 3 parameters that I created. And the full bracket means that they are instance parameters. And then they were associated with the dimension constraint. We did this in the previous class. Check the recording if you want to refresh how this is done. All right, so we have those 2 pieces, and what we're going to do today is just assemble all the pieces into a shelf unit. So I'm going to close these pieces here. And then I'm going to select this family, and I'm going to delete it because I'm going to create it again from scratch. All right, now we're going to do hands-on. Any question here about how these components were created? Pretty straightforward. Okay, we're going to create a shelf unit, and we're going to use nested families in order to drive the geometry. I'm going to, for operations that take some time, I'm gonna do it myself, and then you can watch it, and then we'll do it together again, so you don't fall behind. And please, if you fall behind, stop me. I'm happy to repeat the instructions again. All right, so under the File tab, I'm going to create a new family, not a project, a new family. This is going to open the family editor. File, new family. And you're going to browse to the English Imperial folder of the family template library and open the generic model wall base. This is our template. And notice that Revit has all these different templates that are called ceiling base, face base, floor base, pattern base, roof base. When you choose a template that has that is based on another geometry, it's hosted by that other geometry. So when I create a wall-based family, this family is going to be hosted by a wall it touches. Examples of a wall-based family are the windows, the doors, or the anything that is wall-mounted, like a sconce or a fire cabinet. All those are hosted by the walls, and then if the wall disappears, the elements that are hosted by the walls also disappears. And you've seen it with doors and walls. If you delete the wall, the doors that are hosted by the wall disappear. And there are other types like ceiling base. This is used for creating light fixtures. floor base, if you want something to be hosted on the floor, like I don't know, like a recess floor sink. That is a family that is hosted by the floor. There are some families that are line-based. A line-based family is one that stretches with the input of the user. Pattern-based, those are for curtain walls. That's a little more advanced. I'm going to talk about that in the advanced course. Roof-based is the type of family that you start for something that's hosted by the roof, like mechanical equipment or anything, or a stair that needs to go and hang through the roof. So I'm going to start a new family using the wall base. And then I keep the Mila project open in the background. It's the Mila family project open in the background because I'm going to need it. I'm going to insert it later. Okay, so when you create a new,
what do you mean in the background?
So I have two projects open. I have the Mila house open, and I also have a new family open.
So it's open, but it's two separate files still.
It's two separate files, yeah.
Okay.
Yeah. Okay, so this is the, when you create a new family, Revit automatically opens 4 views. So these tabs that were here, that are here, these are just, I don't know, this is the default behavior of Revit. It always opens 4 views. The reference level, which is the floor plan, the left view, the placement site is an elevation. So you see this placement site. This is a instruction of the template that anything you build for the wall needs to be in the positive side of the wall. So this is we're going to build something in this side. And this placement site is an elevation of that. And then a 3D view that is called view 1. And all those views are also available in the project browser here. Now, I don't need all of them, but maybe what I need is it's the plan and the left view stacked side by side. And so what I'm going to do is tile this WT. I'm going to close the view associated with the Mila project because this is going to come later. Sorry, I need to. If I close it, I'm going to close the file. I'm going to close the file. I don't think I need it yet. I'm going to close the Mila project. So I'm just going to be left with this. And then I need the, I'm going to tile this WT again. And I have 4 views. The placement side, which is an elevation, the left view, a 3D view, and the floor plan. So when we create families, it's good to have these stacked views. Is anybody having trouble stacking this? Again, the way to do this is just type on the fly WT. TW will take them back into tabs, and then WT will stack them in orders. You with me? I want to make this a little smaller here. Okay, so I'm going to sketch what I want to do. This is a wall cabinet, and this wall that you see here is a generic representation of a wall. This wall is not going to transfer into the project. It's not going to be visible. It's in the template to represent what a wall looks like. And it's used there to help you create dimensional constraints that are locked or aligned to the face of the wall. If the family intersects with this wall, is going to generate a void. You know, when a door and a window are hosted by the door, what basically it's a void extrusion that is intersecting the wall and generating the wall opening for you. In this case, what we want to do is that this cabinet needs a wall in order to be hosted. And the cabinet is going to have a width, a depth, and a height. So I'm going to create a reference plane here, another reference plane here, another reference plane here. And then in the elevation, I'm going to have another reference plane here. This is going to represent the height. This is going to represent the width. And this is going to represent the depth. And then I want to be equally distributed. So I'm going to have an equal constraint there. And that is the skeleton of the cabinet. So let's do it together. Let's create the reference plane. So you go into the Create tab, reference plane, or you don't use reference line. This is not going to help you. Reference plane. And we place the reference on the right. The location doesn't matter, but it has to be 90 degrees. Then I'm going to do another one on the left side. Make sure it is 90 degrees. And then another one that is horizontal, a few feet offset from the face of the wall. Escape. This placement site is an instruction. I'm just going to move it away. It doesn't help you for anything. You with me here? Okay, now in the elevation, in the left elevation, I'm going to create another reference plane to represent the height. So create reference plane. That is the height. And you can see on the placement side, there's a reflection of those reference plane. And then the other thing I'm going to do is make sure that all those reference planes that are created are strong references. So you can control select the new reference planes that I created, and in the in the ease reference parameter, you change it to strong reference. Again, control select all the reference planes that you created and make them strong references, because we want the user to have the ability to snap to the edges of this family in the context of the project. The same with the reference plane at the top. This is a strong reference.
Sorry, how'd you do control select? I can only do them one at a time.
I click one and then hit the control key.
Oh, okay, you have to click first. Got it.
Click the control key and then click again. Click again. The ones in the center, these were the original ones. Don't change those. So I think only change the ones we created. So it will be this one, and this one. And this one here. All right, so we'll build in the skeleton of the cabinet. And now that I have the skeleton ready, I'm going to create the parameters. The parameters are going to be the depth, the length, and the height. And these parameters are all going to be instance parameter. I want the user to have the flexibility to change the properties of the cabinet at an instance level. And again, this is my thought process. You may want to choose to do it as a type, but for every variation of the type, you will have to create a new type for every variation of the values. Okay, the other thing is, so we're gonna place those dimensions. So under the Annotate tab, we're going to place an align dimension, the first dimension from the left. Annotate tab, align dimensions. And let's create something that represents the width, the length. So first click is the left reference plane. Second click is the right reference plane. And the third click is a white space in the middle. Don't click on the reference plane because this is going to disengage the string. That's the width. Then I'm going to create another one for the depth. So I'm going to start from here. And notice that Revit likes this dimension to the center of the wall. To change this behavior, check it here. Check this option here that says wall center lines. You want to change that contextual option to face wall faces. And Revit is going to change the dimension behavior to the face of the wall. This dimension is going to represent the cabinet depth. And then I'm going to switch to the elevation, the left elevation. And again, the same, annotate, align dimension. And we're going to place the dimension from the reference level to the top reference plane and place it. So I have the three dimensions in place. Now I need to convert them into parameters. Is everybody with me here? Anybody need more time? Or want me to repeat anything? All right, silence means no. All right, so let's create the parameters. I'm going to start the parameters here using the parameter button. This is the family type button. And the family type button discloses all the information about this family, all the metadata inside the family. Open the family type button. And this is all the information that is associated with this family. And this information is coming from the template. But I need custom parameters here that are associated with the width, length, and depth. So you can create new parameters using this icon that looks like a paper with a little star. This is how you create new parameters. And the new parameter name is length. And it's an instance parameter. And it's going to be on the rest, you just leave it as is. It's the type of unit, its length is grouped under the dimension groups. And it's instance because I want the user to modify the properties of this at an instant level. So then hit OK here. Yeah, question?
Could you tell me how you got to family types again? Sorry.
Yeah, it's right here, this button here. It has a square, like two squares.
Yeah, I always forget about it. Okay.
Yeah. Okay, so that's the, and then Ruth, you hit this button here to create a new family.
Yeah.
And then
okay.
Length instance. Mm-hmm. Make sure you hit instance. All right, and then we hit OK here. And notice that this is a new parameter in the project. And I'm gonna repeat the process 2 more times. Another one for the depth, another one for the height. So new parameter, depth, instance. Make sure you make it instance, and then hit OK. And add another one, and this is going to be height. And it's going to be an instance as well. I am also going to add a material parameter. And this is going to be associated with the solid so that the user can assign the material in the project level. So I'm going to again create a new parameter. I'm going to call it material. But pay attention here. The type of parameter is not length, but it's material. And what this does, this parameter is going to show up with those 3 little buttons that launch the material library. That's what this type of parameter does. And it's going to be an instance parameter as well. And I want to, it will be associated under the materials and finish group of this family type dialog box. And then you just hit OK. So material, type of parameter, material, it's an instance parameter, and then hit OK. So these are the 4 parameters that I created. And let's give it some placeholder values. For the depth, I'm going to say it's 1 feet. For the height, it's 6 feet. For the length, is 6 feet as well. Then I hit OK. So make sure that your dialog box display all the custom parameters with the word default. Default means it's an instance parameter. If one of your parameters doesn't have the word default, that means that we didn't select the type, the appropriate type. So if that's the case on your end, all you need to do is select the parameter, hit the pencil, and change it back to instance. You can also delete parameter, like if you made a mistake, you can delete it here as well. Okay, so you're with me here, change the values, add some placeholder values, and then hit OK. So my parameters are created, but they haven't been assigned to the dimensions yet. So let's do that. Let's assign the parameters to the dimensional. So let's start with the length. Select the dimension. And then in the contextual tab, you'll see this label parameter. And in this drop-down list, you're going to see the list of all the parameters that are compatible with that dimension. And I'm going to associate that with the length. There you go. And don't worry if this is not equally the distance yet. Then I'm going to select the depth, select this dimension, and associate with the depth parameter. And then I'm going to jump into the left elevation, select the vertical dimension, and associate with the height. All right, everything, I have the 3 parameters in place. I need the length to have an equidistance dimension relative to the center of the wall. So I'm going to create a string dimension and use the equal control. So you go to the annotate tab and then hit the align tool. And I'm going to create a dimensional string from here to here to here, 3 clicks. The last click is a placement click, and it's important because it will display the equal control. So place it, and you see the equal control has this diagonal red line. Click on that, and now this is what I wanted. So I have the 3 parameters in place. We can flex it just to check that they are working. So if I change the depth to 2, the reference plane reacts. I'll return it to 1. If I change the length to 5 and the height 7, these appear to be working. Any question here? Anybody behind? So I think we have the skeleton of the family ready. It's ready to get the nested families. Okay, so I hit apply, I hit OK, and let's save this family. I'm going to save it as file save as family and place it in a location you can remember. I'm going to put it in my working project folder, save it in a place you can retrieve it later. I'm going to call this shelf cabinet. Okay, so now I'm going to bring the uprights and the shelves. The uprights will have nested. I'm going to concatenate the properties of the uprights with the properties of the parent family. And then I'm going to load the shelf, place it into the project, and I'm going to concatenate the properties of the shelf with the properties of the parent. So let's do that. I'm going to zoom here so that it's a little clearer. I'm going to make this, it's more readable on your end. Okay, let's load those components. So you're going to load into project. Sorry, not load into project. Insert, load family. And we're going to bring the 2 pieces of the 2 nested families that I shared with you at the start of the class. So navigate to the folder that you downloaded. Maybe it's on your download folder or wherever you saved it. I'm going to load it directly from Google Drive. And under the work in progress, you have these 2 families, the shelf and the upright. Those 2 families I need to load. The shelf and the upright from the Google Drive. You should have downloaded this in the link I provided. The families now are loaded. They should be under the project browser, under the generic models, the shelf, and the upright. They are listed right here. So these are nested families, and a nested family has the ability to inherit the properties of a parent. And that's exactly what we're going to do. The shelf is going to inherit the properties of the parent. The uprights are going to inherit the properties of the parent. So you can drag and drop these from the project browser into the view. So let's grab the shelf, drag it, drop it. And let's grab the uprights, drag it and drop it. And right now, they are not locked. They are not associated with anything. Right now, they're just floating there. You with me here? Any question before I proceed? The next few steps are critical for the behaviors of these nested components. And this is the process of concatenating parameter values. Nested families parameter. And this is an important step when you're trying to build a family based on multiple nested families. So let's start with the shelf. When you select the shelf and look at the instance properties, you are going to discover the depth and the length. These are instance parameter. But right next to the cell property, you're going to see this concatenate toggles. Concatenate toggles, which allow me to associate the value of that parameter with the parent one. So the shelf depth is going to be equal to the parent depth. Whatever the parent depth is, then the shelf is going to inherit that property. So hit OK. The shelf length, again, I'm going to hit the concatenate toggle, is going to inherit the parent property called length. Yep. And so you can, I'm going to flex it to demonstrate that it's working. So if I go back to the family types and change the value of the length to 6, you see how the shelf is also driven by the parent one. If I change the depth to 2, the shelf is also changing its parameter. That's the beauty of associating parameter values that the nested geometry can react to changes in the parent. All right, so I'm going to do the same with the upright. So pick the upright and look at the dimensional properties of the upright. I have the upright depth and the upright height. And I'm going to associate the depth to the parent depth. So you hit this toggle, and then you associate with the depth. Then you hit this toggle and associate with the height. Again, select the upright depth and associate with the parent depth. Select the upright height and associate with the parent height. There's one more thing that I need to make sure. I want both the uprights and the shelf to inherit the material of the parent. of this net, of this host. So if the user decides that this is wood, then the material is going to be transferred from the parent to the components. And the way to do that is the same way. I'm going to select the upright, look at the parameter that is called upright material, the one that says by category, and use the toggle button to associate it with the parent material, but parent parameter called material. And I'm going to do the same with the shelf. Select the shelf and look at the shelf property called shelf material, and use the toggle to associate or concatenate the value of the shelf material to the parent material. So when this family is loaded into the project, you only change the material in the parent, and then the parent automatically is going to inherit the material to all the components because I created these associations. Does that make sense? Okay, so we have the pieces that are parametrically reacting parametrically. I'm going to flex it just to double check. If I change the depth, notice that both the uprights and the shelf react to parameter values. If I change the height, which is on this side here, I'm going to change the height to 7, and notice that the upright also changes its height. And then the length, I'm going to change it to 5, and both the shelf and the family parent do the change. All right, so this is working. Any question here? All right, the next set of instruction is to make the place the components where they need to be and lock it. Lock the components, the nested. And this is just to make sure that the component is in the right location and it's associated with the parent reference plane framework. And the easy one is in order to lock a components, you need to lock it using lock it in X, lock it in Y, and lock it in Z. So let's do an alignment. The alignment is going to allow me to create a lock relationship. And I'm going to do this twice. So if you guys want to check first and then do it yourself. Under the Modify tab, I find the Align button. It's right above the Copy one. And I'm going to align where, destination first, where you want to align the shelf to the face of the wall. And notice that Revit likes to go to the center. In order to force the face of the wall, change this to wall faces. This drop down there. And align to the face of the wall, the edge of the shelf. Align to the right reference plane, the face of the shelf, and lock it. That's all we need to do. I'm going to repeat it. I'm going to do, and let's do it together.
Sorry, Cesar, where are the links to the family you created, the shelves and all that?
Where?
Yeah, you said you send the links to the new family.
Oh yes, I did. It's in today's folder in the
Okay.
In the Google Drive. I also posted in the chat panel. Do you see the chat? Do you see it there? If not, I can repost it. Let's see. Chat panel. Here it is again.
Thank you so much.
So you may want to load those components and place them into the project, and then you have to associate the parameters. Okay, so any other questions? Okay, I'm going to align it, do the alignment operations. Go to the Modify tab, hit the Align tool. Align, select the destination first. Face of the wall. What do you want to align to the face of the wall? The edge of the shelf. And lock it. Locking it is very important because that's going to prevent the shelf from arraying it in a different location in the X direction. And I'm also going to lock it on the right reference plane. So the same thing, align to the right reference plane, the edge of the shelf, and lock it. And that's all I need to do. There is a lock on the X and there is a lock on the Y. And this is going to prevent the shelf from moving in a different direction. Everybody with me here? Okay, and so I'm going to do the same with the upright. I'm going to create 3 copies of the uprights because one upright is going to be placed here, another here, and another there. And on one end, I'm going to have the upright locked to the left side of the upright. Then this is going to be locked to the center. This is a little lock. And then this is going to be locked to the right. So let's put it in place. I'm going to create 3 copies of this. So use the copy to create a copy there and a copy there. When you review the properties, they should have exactly the same instance parameters. All of them have the concatenation as expected. And let's start with the center one. So I need to lock it in the X direction and the Y direction. Let's start with the X direction. Same thing, we're gonna align. Go to the Modify tab, align. So align to the center of the center reference plane, the center of the upright, and lock it. We'll continue to the other one, the right one. Align to the right reference plane, the right face of the upright, and lock it. I'm just locking on the X direction. And then align to the reference plane, the left upright, and lock it. Don't forget to lock. Lock is very important. If you flex the family and the family is not adjusting, is because we missed this opportunity. We have to redo the align in order for that to happen. So I align in X this here, this to the center, and this to the right.
How did you change the face from the center line?
I'm going to do it again. I'm going to remove the constraint. Align to the center reference plane, and just hit the center of the upright.
Yeah, but when you're on the left and the right, when you wanted to align to the face, the outside face, not the center line.
It's the same thing. You just pick the face. Let me show you here. Align
Okay.
to the reference plane,
Yeah.
the face, and lock it.
Okay. It seems like it's only letting me choose the center line, not the face of the shell.
Hit the tab key. Maybe that will discover it.
Okay.
Um,
Okay. Thanks.
so you go, I'll do it again, align here. And when you get here, if you hit tab, you must select the face and then lock it. Did it work, Ruth?
Yeah.
Okay. All right, so the three uprights are anchored on the X direction to the reference plane. Now let's lock it in the Y direction. So I'm gonna do 3 aligns again. Align the upright, the back of the upright to the wall for the 3 uprights. So align again. We're gonna do the align a lot here. Align to the face of the wall, the edge of the upright, and lock it. Oh, I'm getting this message. Why am I getting this message? Aligned to here, here, and lock it. Oh no, this is just a warning. Constraints between geometry and family. Revit doesn't like to align face of a solid to a reference plane. But just hit OK here. Align to the face of the wall. And you know what? I'm going to do this. One of the things to make sure that I'm aligning to a reference plane and not to the wall. That's what Revit doesn't like right now, is to hide the wall. And the way to do that is you go to visibility graphic, type VG, and hide the wall here. It's not going to impact anything. But now you're going to be left with the reference plane. That's what Revit is complaining, that these uprights are better off aligned to reference plane than to geometrical faces. And that's what that constraint was about. So let's repeat the align 3 times again. And if you, I undid in order to get to this point, and then I type VG to hide the walls and expose the reference plane. So I'm going to pick the reference plane when I align. So let's do it again. Modify, align to the reference plane, not the shelf. This is the shelf behind. We don't want to do that. To the reference plane, the upright, and lock it. And notice Revit doesn't complain anymore. I'm going to repeat it again. Align to the reference plane, the center upright, and lock it. Escape. And I'm going to do it again. Align to the reference plane, the face of the upright, and lock it. And Revit's happy now. So Revit doesn't like to do that. And so the uprights are where they need to be. And we can flex it. So go to the family type and let's change some parameter values. I'm going to change the length to 6. And you see how it changes. I'm going to change it, the height to 8. And you can just hit apply so that you don't have to be closing and opening the dialog box. And you notice how it's changing the elevation. 7, apply. Let's change the length to 4, 5. And the uprights are flexing where they need to be. I'm going to change the depth to 2 just to test it. It's working nicely on my end. Okay, any question here? We are like 75% done. Now that we have the uprights where they need to be, then I can take care of the shelf. I have a single shelf that's sitting on the floor, but I want this to be parametrically driven by the height and by a number of by an array number. So this is the elevation of the, I'm going to make this bigger so you can see. This is the elevation of the shelf. And what I want is parametrically distribute this shelf as an array from the reference level to this reference plane. And so this shelf needs to be copied a number of times from the reference plane to the top plane a number of times. And this is going to be n. And n, it's going to be a parameter. I want the user to decide how many shelves to distribute between the bottom and the top of the shelf. So n is a variable, and it's going to report integers. You cannot have like 1.5, 1.3. It's going to report integers units, and I'm going to use it in as part of an array operation. So okay, let's do that. I'm going to need to create one more parameter that is called n. N is the number of shelves. And I'll do that in the family parameters dialog box. So open the family parameters dialog box. And I'm going to create a new parameter. You can create it right here. It's the icon, like the piece of paper with the star. And I'm just going to call it n. N represents the number of shelves. But it's going to be an instance parameter. And it's going to report integer units. It cannot have decimals. We need complete and equal distribution of shelves in the vertical. So it has to be integer. And then I'm going to group the parameters under the dimensions as well. So these parameter is actually what is the group this parameter is going to fall into. If it says dimension, it's going to be placed under the dimension group. So again, open the family types, create a new parameter. The name is n. The number of units is integer and is an instance parameters, and group it under the dimensions group. All right, so I'm just going to hit OK here. And the default value, I'm just going to say 4. So that means that the shelf is going to be repeated 4 times. You all with me here? Make sure all of these parameters says default. Default means that they are instance parameter. If one doesn't say default, just go back and edit it and change it from type to instance. Okay, so hit OK here. And we are in the final steps. I'm going to make the elevation a little bigger so that's useful for you. So this is the elevation of a family. I'm going to diagram what I'm going to do. I'm going to create an array. And in Revit, you have two ways of creating an array. You select the first element, then define the second element, and then you tell it how many times you want to array it. So this is your element. You tell them where the second element goes, and then how many times you want it to be repeated. This is the default way of creating an array. If n is 3, then it's going to create 1, 2, 3. If n is 4, then it's going to create 4. But the distance between the units is driven by the distance between the first and the second item. That's how an array is created. Another way of creating another method of creating an array is defining the first item, then selecting the last item. I'm going to call it L, and then define how many elements are going to be distributed in between. So n could be 3, could be 4, could be 5. So out of these two methods, this one seems to make more sense. You select the location of the first element, select the location of the last element, and then you define how many ends fall in between. In the case of my shelf, the shelf at the bottom is my first element. The location at the top is the last element. And then how many elements in between is going to be n. All right, let's do an array. I don't think I've taught you guys how to do an array. But here's how. I'm going to do this twice. So if you want to watch first, that's fine. Then I'm going to undo and do it again. I'm going to select the shelf, and I'm going to create, just very quickly review the properties, make sure that all the parameters are concatenated. The shelf material, the shelf depth, the shelf length. This should be grayed out, and there's an equal sign associated with that, telling you that these parameters are concatenated to the parent one. All right, so I'm going to select the bottom shelf and hit the array button. The array button is under the modify tab. And don't worry, I'm going to repeat this again. I'm going to array it, and then in the method of creating an array, I'm going to choose the last. Last means the distance between the first and the last item. And the number of elements, I'm going to change this to 4. So make sure this checkbox says constrained. The method is last, number is 4. And I pick a distance from the first element to the last element, and then hit escape. And this is the array. I'm going to repeat it again. So let's do it together. And stop me if you want me, if you're falling behind. Select the bottom shelf. Hit the array button, modify tab, modify panel. It's an icon that looks like 4 little squares. In the options bar, the number of instances is 4. The method is the last, and enable the constraint. Constraint is important because it guarantees that the array is going to be perpendicular. All right, 4, last, constraint. Then pick a point in the at the ground level. I am in the placement site elevation. It's available on the product browser. Pick a point at the ground level. Then pick a point, the last element, 90 degrees. And then hit 4 and enter. And there you go. this is an array. Look at it in the 3D here. But I'm not done yet. I need to make sure that the n parameter is correctly associated with it. And I also need to make sure that the last, this shelf here, is properly aligned. Any question here? We're getting close to finish this family. So I need the top, I know that the bottom shelf, it's aligned because I did that the first round, but the last element is not locked yet. I need to make sure that the top shelf is always locked with the top reference plane and that is locked to the back of the wall. So I'm going to do that now. So in the placement side, hit align. Again, align to the top reference plane, the top shelf, and lock it. Again, align to the top reference plane, the top shelf, and lock it. All right, so the top is locked in the Z direction. In the left elevation, you can open it in the project browser. I also must be sure that the top shelf is locked to the wall or to the reference plane of the wall. So I'm going to do align the top shelf back surface, which is this tiny surface here. I am in the left elevation and I'm locking the top shelf. Align the back of the reference, the back of the top shelf to the reference plane. Remember, Revit likes to align to reference plane and lock it. So again, align, I'm in the left elevation, align the back of the shelf to the reference plane of the wall and lock it. And when we do this, we guarantee that the array it's always going to be perpendicular, that it's going to be along the wall, that it's not like floating away, etc. Okay, and then the final step.
Did you lock it to the top of the wall too, in that on the left? Or was that locked somewhere else, I mean, aligned?
Let me see. I lock it to the reference plane. This reference plane.
I mean, did you align it to the top of the wall on the left, or was that? Oh, I see what you did. Okay, never mind.
Yeah. So I don't have to lock it in the front elevation. I lock it to the top of the to the top reference plane.
Okay.
I don't have to repeat it again, because I did it already in the placement side.
Okay.
But what I did in the left elevation is to lock the back of this to the reference plane and lock it. All right, and the last step is to associate the array, the instances of the array to the n parameter. And I'm going to do this twice if you want to watch first. In the placement side, I select the array, and you see this pops up here, this thing. I'm going to select that line, and in the label that appears in the options bar, associated with n. I'm going to undo and repeat. Undo. Select any element of the array. When Revit array, it makes the array into a group. So that's why you see those dashed line around the shelves. That's a visual indication that this is an array. Select any of the shelves And that's going to, when you select that, you're going to display the number of instances as a string dimension. Select the string dimension, and in the options bar, associate that string dimension with the parameter called n. And we are done. Now let's flex the family. I'm going to make the 3D view my my view here. I'm going to change this to shaded, and let's see if it works. In the family parameters, now I'm going to change the depth to 2, apply. I'm going to change the height to 8, and notice how the array automatically equally spaced between it. I'm going to change the length to 6. Oh, you see, that's what I need to do. The top shelf needs to be align locked to the one of the reference planes on the left and the right. So I'm missing that step. So and I can do that on the top floor. So that's why we need to flex to make sure that the array is working. So I'm going to select the top shelf. And I need to align the top shelf, or maybe you can do it here on the placement side. Align the right edge of the shelf to the right reference plane and lock it. So again, I am in the placement side. I'm looking at the top shelf. I'm going to align the edge of the shelf to the reference plane and lock it. So using the align where? The reference plane, what? The edge of the top shelf, and lock it. And that should take care of that issue. All right, now I'm going to try it again. I'm going to change dimensions. The depth is 1, the height is 7, the length is 5, the number of elements is 5, 6, 7, and you let the user decide how this shelf should work in the context of the project. Now, if I want to go by the book and look at the Miller house, I know it has 5 equally distant spaces, so I'm going to leave it as 5. I'm going to assume that it's about 1.5 feet, so it's 1.5. That the height is 7. That the height is about 7 foot, and then the length is about 6 feet. And I don't worry about the material here. The material is going to be used, is going to be applied in the project. This by category is going to apply in the project. Oops, I did the wrong thing here. This is 1.5 feet. Okay, I save this family. And then I'm going to load this. I'm going to open the Mila house, any of the Mila houses projects that you have. And we're going to place it against a wall. This is a wall hosted family. So save the family. I'm going to open the project, open a project. I'm going to open the Mila house that I have saved on my folder. the Mila family, this guy. And then I'm going to load this into the project and apply a material. So this is the one I had. I'm going to delete it. I call it differently. And I'm going to go insert, load family, go and find the wall unit, the shelf that we just created. So it's under, I save it where I save it. Where did I put it? Let me go back here. File. File, save as a family. Oh, I was saving it on this 1031 folder. Okay. It's the shelf cabinet. So insert, load family. And shelf cabinet, here it is. It's a wall-based family, so it's going to need a wall in order to create it. It should be saved. The family should be available under the family. You can load it directly from the generic models category in the project browser. Here's the wall shelf unit. And then you just drag it and drop it. And there you go. If you want to put it into 0, change the elevation from level to 0. And then to change the material in the project, it's an instance parameter. Select the plywood material from the material library. And because the material is concatenated to the nested components, the shelf, the upright inherit the parent material. And so this make the family flexible enough so that it can be loaded into different projects and be assigned with different materials according to the design intent. And if the user needs to refine this, you know, when I look at this, maybe it needs to be a little higher, like 7 foot something, then you can select the family, and because all those are instance parameters, then you can change the height, let's say 7.3 instead of 7.0. The shelf automatically equally spaced, etc. You can change the length here. You can make it higher, or you can change the depth as well. So hopefully it works for you guys. If not, the files are there. We are at the top of the hour. Can you guys let me know if anybody did it work for anybody with a thumbs up? Yanjin, Mafi, awesome. And yeah, so this is just a small sample of what it is to build a fully parametric family. This is the way you would build the same logic or similar logic would apply for like wall cabinets in the kitchen. So an additional, if we're talking about a wall cabinet, then we would add the door as a nested component, and then lock the width and height of the door to the parent parameters. The handle is another nested component. The glazing could be another component with a different material. And then you can build an entire library of components just by being smart about how to assemble and nest one component inside another. All right, so I'm going to save this file. I have a few minutes left. If any of you have any questions, let me know. Otherwise, I think we could, you can stay over if you want me to troubleshoot any of this in the background. If you have any question about Revit, feel free to ask now. Make sure if you're interested in the advanced class, contact Lana, and the class is getting formed for January with additional topics. Any question? Jim, you have any question?
I had one. We're looking at purchasing a new specification platform. SpecLink is one that I've used before. Are you familiar with it?
Yeah, we use SpecLink at the Gensler. Yeah.
So do you see the utility, and is it actually functioning to link specs to Revit models now?
Yeah, I think the tools have evolved robust enough to associate element instances with material specs. It's the way it works right now. The assembles in Revit are connected with an assembly code that it's associated with this classification system. But this is the out-of-the-box one, and what an out-of-the-box, and this is Uniformat, that I don't think Uniformat is as wide popular as master format. And what the tool does is to, instead of connecting with the out-of-the-box assemble, it connect with the spec master spec database that is part of the features of SpecLink. And by adding these these codes, then it can be easily connected to the spec book. It works. I think. I think the only thing that I think was a little tricky is when you edit in conjunction with multiple people. I can't recall if a SpecLink only allows you to one person edit the database at a time. Maybe not. Maybe it has changed, but it's been like 3 or 4 years since I last used it. There was another product.
Yeah, there's a new one that Deltek has launched. It's only about 6 months old, as I understand, and it works in a similar way. The interface is a little different. So we're testing both of them right now. So I was just curious if you see this as a direction the bigger firms are going, and actually really integrating it in their production.
Yeah, I've seen this successfully integrated. I mean, there was a project. I don't think it's very popular on the West Coast, but in the East Coast, I worked in a project where the annotations of the details were actually spec numbers.
Like keynotes.
Keynotes, yeah. You work on those, Jim? Are you?
We don't use that system extensively, meaning not directly tied to a spec section, but we do use keynotes a lot, and that's one of the interesting features, I think, of this link capacity is that you
Yeah.
can start to think that way about how you display information on a sheet. Yeah.
Yeah.
Well, anyway,
Uh,
thank you for that. And thank you for your teaching this semester.
Yeah. There's another product called eSpecs.
Yeah.
And that's the one from Deltec, right? Yeah.
I don't think that's the one, but I've heard of that one.
Yeah, and these BSD spec link. That's the one you're talking about, spec link. Right?
Yes. Yes.
That's the most popular one
Yes.
that I know of. And run it by your spec writer, because some spec writers are very picky about the way like books needs to be formatted, and
Right.
I think in my previous firm in Gensler, Vivian was really unhappy on the amount of customization that it can be created within the templates.
I heard that too.
Yeah.
We actually do a lot of our own specs, so it's of particular interest for that reason.
Yeah.
Thank you.
All right, guys. So we hit the end of the class and the course. I hope you learned something about Revit and enjoy the class. Feel free to follow me on LinkedIn. I'm going to try to add you as well. And if you like the way I teach and you can endorse my skills, then that's going to help me secure more followers and more classes in the future. So I'll add you in LinkedIn for future communications. I offer some support related to the content of the course applied to your job. So if you have any question and I can be of any help, I can just shoot me an email. And I'm happy to respond a question here and there. And also stay tuned for the next class. Yeah. Yeah. If you want to stay over after class, you can do that, or else, this is it.
Thank you so much, Cesar. This was really a
Cesar.
great semester.
Thank you.
Yeah.
It's really great.
Awesome.
Thanks.
Yeah. Awesome.
Very useful. Thank you.
Stay in touch, guys, and have a good Revit afterlife.
Excuse me, Cesar. I think I have to hit you up with a few emails
Bye.
just concerning about overall workflow.
Okay. We can follow
Yeah.
up on a side.
Okay.
No problem. Yeah.
Yeah, because I'm not sure if it just like pertains just closely to our firm, just because we do a lot of TIs and we
Okay.
do a lot of work with the subs under contractors. So we have a lot of times mixed teams with people who have only AutoCAD or who work with Revit as well. So it's like a multi-software
Thanks,
workflow
Mafi.
sometimes that we're working with.
Okay. Yeah, if you want, I'm happy to spend I don't know, extra time with you in a future date. Just ping me and I'm happy to discuss it.
Okay.
What a specific is about that.
Okay. Thank you so much.
All right.
Thank you.
Bye, Jiang. Bye,
Yeah.
Sarah.
Bye.
Have a good
Thanks.
one.